how is it that we would measure an acceleration? What did we talk about last week? It's meter. We only spent just a very short amount of time on it. It was meters per second something. Meters per second squared, that's right, okay? So acceleration is just a little different. Meters per second squared, meters per second, and then time. Okay, so acceleration can also have a negative value, and the example we gave is if you are driving and you have your foot on the gas pedal or the accelerator, you let that off, you will have a negative value. And that's just deceleration rather than acceleration. Okay. Now, what's true about all velocity as opposed to acceleration? Acceleration can be negative, but what about velocity? It's always going to be positive. That's right. Okay. So just a little bit of information we want to go over as you look over on that board. Okay. On the 28th, which is Wednesday, what do we see? What's due? You have an assignment, your vocabulary, and the papers that will be handed out here shortly today. And then be given time tomorrow. For some of your older siblings or brothers and sisters, one of the things that I believe in, especially as we get further into this curriculum, very rarely would you be given something to work on and it's due the next day. Okay. Maybe that was the way that we were in school, but times change. And out of everyone in here, we're all busy. I'm busy, you're busy. So what we ask of you is just take advantage of that time and utilize it so that when it is handed to you, if you have problems, you can take advantage and ask at that time or the following day, because it is front, back, so I don't know if you call that 2 pages or 4, okay? And again, it's not due tomorrow, it's due on Wednesday, same as your vocab terms. So if you have them done, it's one less thing to have to think about, okay? But my point is, you'll have today and you have tomorrow to work on those. And the only aspect about tomorrow's, we'll start talking about different types of momentums and how you calculate that, okay? So, with a little bit of time here, we want to discuss these forces, and then we'll move on to getting that problem solving out. And I have one behind the board as well that we'll discuss as a group. Yes. Yes. And you'll laugh at this. Well, maybe you'll laugh. I don't know. What I do is I just walk around and, for instance, your terms are on the back page, okay? And all I do is I walk to see if you have it done. And I just pick one term out to look at. Just people like to make up their own scientific terms in there. And, yeah, that's not going to pay off in the throughout the course of the school year. And it kind of had occurred to me, for maybe yourself or you're going shopping with your parents, self-checkouts maybe became more common. I want to say 2006 is maybe about when they first started showing up in your Walmarts, your Kmarts, or think Target's had them. I think Walmart was the first one to explore that possibility. Why would you have self-checkouts? Yeah, less workers there. So what the store is depending upon is you individuals, if you purchasing something that you're going to do what about it? Trustworthy, honest, okay? So one of the things that even throughout this course of this curriculum, you're not helping yourself if you just copy someone's answers all the time, okay? Just being honest about it, that you're going to be better off in the long run. So people can maybe slide through the checkout lines and you're carrying that bag and, oh, there's no receipt there. And I don't think that's very common, because I think people would agree that people in the Midwest, we're very trustworthy people, correct? I would like to think so. And now I think if you're going through purchasing something at Sam's Club, they have a self-checkout or their checkout line. And I think what happens is they'll take a device and scan your receipt and then look in not your checkout basket, your shopping cart, and just pick one or two items and click that. Something must pop up on their screen that says maybe green check or red X or something like that. So that's what kind of reminds me of looking at your vocab terms. I just pick one or two to look at and just go from there. Because to me, it's probably more work just trying to think of something to write in there, unless it's just absolute garbage, like I hate minions or something like that. I don't know. Nothing really sticks out in my mind, but some people just in the past have just made things up and wrote in there. Okay, but that's again on we see on Wednesday. Okay. What would happen if I can think of maybe a demolition derby, for instance? You have two vehicles. Of course, the idea behind that is, why would a driver be always going in reverse? Why not just go forward and plow into someone? True, but something before the engine, too. Somebody said it. Radiator, okay? So once that gets punctured, you're going to lose your coolant, and then your engine's just not going to run, at least not for much longer. So perhaps you're driving backwards and you're running into or backing into a vehicle, same size, same speed, they run into one another. What's probably going to happen? Is there going to be a net movement between the two? But if you have something same size, same speed, running into one another, it's not going to have what we call an elastic collision. Or excuse me, it is going to have an elastic collision. They hit, and there's no movement one way or the other. So that would be what we call a balanced force. And one of the, you think like football movies, of course, one that was way before your, well, not way before your time. Remember the Titans as ones, and then one of the Friday Night Lights. I've never seen that. It is? Okay. How about We Are Marshall? Has anyone ever heard of that? That plane crash, and that was in before my time. I think it was in the early 70s, but I don't know. Matthew McConaughey is one of my favorite actors, along with Will Smith, and so I like seeing movies that they're all in. But McConaughey played this Jack Lingo as a head football coach, and one of the things he's trying to illustrate to his linemen. Now, you kind of laugh at the premises of this, but this true story about, like what you had said, a plane crash that had wiped out the entire football team. They put one together again of soccer players, baseball players, everything else. Maybe never played, and he's trying to explain to one of his linemen, okay, and even in your case, if you're going to tackle someone, we see this in the NFL a lot. probably more than what you think you should. When I had coached junior high football, every day we started with tackle drills. Every day, tackle, tackle, tackle drills. Why do you not tackle up here around the shoulders? The low man wins. That's a good way of looking at it. So in this movie, he's trying to illustrate that you want to get low and have more leverage. If you have more leverage, you're probably going to change that balanced force to an unbalanced force, which will then lead to a net movement. Okay? So that's a good way of looking at that. Low man wins. Well, if there's any just crazy how someone that big can move that fast. Anyway. Okay, does everyone have this information that wants it? Okay. So what we want to do then, okay, is as we're moving forward, one of the things that I had learned years ago from a college professor, he said, one of the things you want to think about, if an instructor or another professor writing something down on the board, chances are it's going to be something that you're going to want to pay close attention to. But there again, this is that freedom of being in high school. Write it down. Don't write it down. I suggest that you do, but there again, that's your opportunity to do so. Because one of the reasons we say that is there's some unseen variables in there. You have to use your scientific intellect to solve this. What do you have to do in it? That's what we're getting to. We'll let you write it down first. Then we'll proceed forward. Gesundheit. I don't know, I was, as the zoology class was winding down, getting ready to go, I just looked out there and I picked out, I don't know, 4 or 5 football players, and I said, who do we want to pick on? That's what they gave me. So, yeah. So to elaborate on that, we would say, perhaps, what was his, what would you guess? Okay? You're correct. It is the acceleration. Why would that be, though? Gives you two velocities and a time. Okay? Okay? So one of the things that we talked about last week, okay, this is not starting from rest, which would mean 0, okay? So as your a student is winding the way, I don't know, down the basketball court, it's a little more tougher then because you got that darn ball you have to bounce as well. But in this case, okay, because is a person always going to be running at a constant speed going down the football field? Maybe somewhat if they're on the sideline and there's no one in front of them. I mean, ideally you want to be able to accelerate a little bit, but there's just not enough distance to be moving, for instance, at a constant speed, maybe still accelerating, but why would it be that in this case he may be slowing down at certain times? Because when we talk about acceleration, yes, it's a change of speed, but in order to change that speed, you may also be doing this, which is changing what? Direction. You either change your direction, which is also going to have an effect on the acceleration. So, as we look at this, what type of variable is this 2.18? Okay, it's a velocity because it's meters per second. Okay, what also is 4.17? It's also a velocity because it's measured in meters per second, and then we have 0.87 seconds. So this is one of them aspects. Okay, you've read the problem. The next thing we want you to do is what? Yeah, take down your information or write down what you know. But the problem with this is, what formula will you be utilizing? The acceleration formula, which means there's two velocities, but here you need to decipher which one's which. So we use the terminology in the question to help you with that. So we know that there's 4 variables in the acceleration formula. Acceleration, final velocity, initial velocity, and time. So with that, what do you think is the final velocity then? Okay, and it is because what we see here, winding through the defense, he's moving at 2.18 meters per second. Then it says if it's 0.87 seconds later, okay, which speed happened first, which speed happened second? If this came later, which one of these two numbers came first? 2.18, and when you said that earlier, you were correct. Okay, so the initial velocity then was 2.18 meters per second, therefore making 4.17 meters per second final. What else do we know in this problem? Okay. And then we're finally solving for acceleration, which we don't know. So therefore, there again, once you have this information wrote down, now you just look at what your formula tells you to do. Okay? So, in this case, what do we do with the acceleration? Well, that's on the left-hand side. So what do we put on the right-hand side now? 4.17 minus, okay? And if we really want to be specific, we're going to do that first, okay? We want you to subtract those first. That's why we put the parentheses, then divide. Okay? What is that, 0.99 divided by 0.87, and then that gives you an acceleration of what? 2.28. Okay, rounding to the nearest hundredth, 2.28 meters. Okay, 2.29. Meters per second what? Right. Now, I'm not so worried about when you're labeling that, if you're solving for the acceleration. What I would be concerned about is if you see that in the problem, where you see a number labeled in meters per second squared, that we go, oh, well, that's going to be an acceleration then. Okay. So, with this problem, left outside, are we on the bus? Yes, 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 yes. Left middle. Okay, middle. Right middle. Right outside. Okay, now the big one. Do we trust any one of you driving the bus? Oh, that's because they just have a commercial driver's license. Right. Could be a big problem. That's right. Okay, so can we erase this problem? Okay. Otherwise, you can always go back to the science channel. Okay? So, one of the things we want you to get encoded on your brain and remember is this here. Now, you don't need to write this part down, okay? What we're illustrating here, okay? At some point, someone's got a squeaky desk. Whoever's doing that, please stop. Okay? So, if we want to know the circumference of this, okay, we don't want everything inside of here, because that's the area. Okay? And if it was 3 dimensions, we'd be solving for the volume. We don't want that either. So, if this distance right here, I'm going to say is 10 inches. So if we want to know the entire distance around this, the circumference of a circle, we know we can bypass the 10 and put 20 there. Does anyone know the formula for circumference? It's 2 pi r. So you could put circumference equals 2 times 10 times 3.14. Or we said you can bypass that 10 and just put 20 times 3.14. My point is, which one of these numbers or variables are you always going to use in a circle? It's a constant. That means you use that every time you're solving for the circumference or area or volume of a circle. Cones, spheres, you're always going to use pi because it's a constant. One of the constants I want you to get down as well is it's a constant due to the gravitational pull on the earth that gives everything its weight. So you can write this down, okay? But this acceleration is due to gravity and has a value of 9.8 meters per second squared. Now, the only time that you would use that constant is when something is free falling. Okay? So if you let this go, gravity has an effect on it. It's moving in the vertical plane. That is gravity. Moving in the horizontal plane, okay? Yeah, gravity is going to have an effect on it, but not the same as going vertical. So you would calculate this acceleration, just like what we did here. We would not want you to write in, oh, well, what's his acceleration? Well, it's due to gravity. It's 9.8. No, that's not the case because that's moving in the horizontal plane, not the vertical. Does that make sense? Okay. So, let's see here. I think there's a, I don't know, flipping through the channels Saturday night after the Twins were victorious again. No one shares the enthusiasm of this up here. Baseball. Just not the Twins. If it's not the Twins, who it is? Who is it? Don't say New York or Boston. Okay. Well, it doesn't matter. But anyway, Mel Gibson had a movie on. It was What Women Want, but that's besides the point. How he, if anyone, guys, if you can solve that question, man, you can become rich. What do women want? Oh, I don't know. It's a point to ponder, I know. Yeah. But anyway, with this, I know Mel Gibson made his one of his debuts in Lethal Weapon. I think that was yeah, that's a good movie. But in that part of that movie, they need to land on a big air mattress. Okay? So one of the things that happens, okay, is that as we're looking at this, or maybe there's a burning building, okay? So here's this 5-story building, okay? Who can we pick on? Okay? Mr. T. I pity the fool. Yeah, okay. You know who Mr. T is? Part of the A-Team. He had a whole bunch of big beard. Okay, you're going to work on a mohawk now? You don't want to see yourself in a mohawk? That'd be pretty cool, though, wouldn't it? Yeah, that's what we'd always... I pity the fool. Am I saying that right? Maybe yes, maybe no. So we got Mr. T up here. Okay? So here's Mr. T. Of course, Mr. T's, he's ripped, so. Okay, so as Mr. T here needs to land on this air, it's not floating in the air, sorry. I didn't quite get that right. So here's this air mattress. We'll make it a dotted line because it's filled with air. Okay. So Mr. T got this building that's on, and hopefully this never happens. Okay, but that's the idea. Hopefully this never happens. You got this burning building here. So it's getting closer. It's moving in that direction. So you got Mr. T here. He's got to land on this air pillow. That's about maybe 8 to 10 feet away from the building. Oh, the laws of physics say, I want to land on that, so I better take a little bit of a running jump, and as I jump, try to land on that pillow. You get a little bit of speed behind you, you're going to hit that pillow? You're correct. You're shaking your head no. You're right. Okay? All of a sudden, I don't know. You didn't do that. All of a sudden, splat. Whoops. Okay. So ideally what you want to do is just slowly step off of that. Now, that's one of the things, it's so counterintuitive to think of that, because you're going to have, hormones are very powerful substances that the human body makes. Adrenaline is one of them. And sorry, I don't mean to get off on this side tangent, but don't mind, that's fine. How many people love Halloween? Okay? What was it? Organic class we're talking about. The seniors, some of them wanted to go see, what was it, scary stories you tell in the night or something like that. It's a version, step up from Goosebumps or something like that, maybe. I don't know. But some people like seeing those scary movies. Um, It, Stephen King's It. So It Chapter 2 is coming out. How many of you are counting down the days that I am going to that? Okay. But anyway, just north of Sioux Falls on the interstate, there's I wouldn't call it a new business. It's called, what was it? Not Scary 29. I can't remember because it's off of Interstate 29. This guy purchased a building. It's going to be a haunted house that opens up. I don't know if it's in the 1st of October, but some people just live for that, going through a haunted house because they just like that rush of adrenaline coming through. Is that anybody out here besides over there? We like that? Okay. Okay. Could be the same thing. Okay, what's happening is you're having this flood of adrenaline going through your body. And at this point in time, okay, in more of a, let's say what do I want to say, a sad but true story. Again, before your time, I remember it was on September 11th, 2001. I was administering a A&P exam to some of the students, and a neighbor teacher just came over and said, "Oh my God, a plane just flew into the World Trade Center." And at that time, because a little Cessna had just, which is a single engine plane, just went into the World Trade Center. Probably within a year before that. So I thought, oh, I don't know. I didn't see the news. I didn't know what they were getting at. Come to find out later, it was one of a jetliner that, of course, flew into the North Tower. And unfortunately, an hour later, one flew into the South Tower. Okay. But why did the one that got hit second fall down first? Does anyone? I would be surprised if you knew. I wouldn't. Well, what happened is it hit lower. Okay. So then, as all of that jet fuel is burning inside that steel skeleton, these I-beams, they're eventually going to reach a critical temperature to where, how many of you have worked with number 9 wire before? So you cut that. If you can't cut all the way through it, then you take that wire and start doing this. Once you start moving that, what's happening to that point where you cut it? It's getting what? It's going to get weaker and it's getting hotter. Well, just picture, I don't know how many tons of concrete and steel above where that second plane flew in. And once that gave away, it's kind of like a domino effect going down and down and down. Unfortunately, at the time, I thought, shoot, I'm thinking everyone got out of that building. Well, unfortunately, that wasn't the case. But on footage of that, people who were trapped in some of these upper floors, if you listen in the background, you hear just glass shattering time after time after time. Well, people were trapped in that building. Burn or jump. And that was really kind of sad on that day. And that's what would happen. And but in this case, we got a happy ending here because Mr. T, he's going to hit this just fine. He's not going to get this running start and then miss. So ideally, what we're looking at here, we're starting at about a velocity of 0. Okay? And we can calculate that speed upon when he's going to hit. Because for every second that elapses, so if it's about a 5-story building, we're going to go 1, 2, 3, 5. For every second that goes by, so if it's 5 seconds, that's why we put them on here, that it's going to move 9.8 meters. Okay? So in a problem, it might say something like, okay, what was the velocity, what was Mr. T's velocity after 5 seconds? Okay? And that might be the only information that you're given. We started from rest. So that would be one of those aspects. Well, we know that this is the acceleration. Okay? We don't know what that was. He started from rest, and then there's 5. Okay? Because there's a problem that's kind of similar to this on your paper I'm going to be handing out here shortly. Okay? And then the last thing I'm going to say is, anyone ever watched The Little House on the Prairie? It's reruns now, of course, but let's say you're maybe a pioneer that had just found a air shaft or a well. Well, we don't have this, I want to say this equipment that we have now. So if you want to know how deep that shaft is, you could take a rock or something, and then you count in your head, you let it go 1 second, 1002, 1003, until you hear something go sploosh or hit the bottom. And what you're doing is, you know, have this known value that you can try to calculate the depth and the speed that was moving with just a simple rock. All right, so we discussed a couple problems. Any questions over this here? So Mr. T survives. I don't know what his final velocity was. Well, whatever 9.8 times 5 is. But we will pick up with this tomorrow. I'll give you your papers. Those are due on Wednesday. Tomorrow, you have a lot of time to work on them in class. Okay, so again, we'll pick up with this tomorrow.